Today we're going to go ahead and introduce you and start getting you comfortable with the unit circle. We're going to start by doing that with the special right triangles that we explored a couple lessons back. So it says, what is the value of A when the hypotenuse is 1 unit? So here is our 30, 60, 90 right triangle, and it's got our pattern that we reviewed. Across from the 30 degrees is A. Across from the 60 degrees is A times the square root of 3, and the hypotenuse is 2A. So it's telling us that the hypotenuse is 1 unit. So this 2A would be 1 unit. So we can set that 2A equal to 1. We would divide that by 2, so A has to be 1/2. So it tells us to using that value of A to label all 3 sides of the triangle here with no decimals. So we would say our A value is 1/2. Our hypotenuse was 1. And so here on the side opposite of the 60 degree would be 1/2 times the square root of 3, which is the square root of 3 over 2. So there is our 30, 60, 90, and we have just labeled it with our new ones having a hypotenuse of 1. Now it says, what is the value of B when the hypotenuse is 1 unit? So in this case, we're looking at a 45, 45, 90 degree triangle. And we know that in that case, the B value is both sides that are equal. And then our hypotenuse is B times the square root of 2. In this case, it's saying the hypotenuse is 1, so we are going to take 1 and set it equal to B square root of 2. To solve for the B here, we would divide by the square root of 2. And so we get 1 over the square root of 2 is equal to B. Now we don't want to leave that like that. We want to go ahead and rationalize our denominator. So I would take that square root of 2, 1 over square root of 2, and we would multiply over the square root of 2 times the square root of 2. That gives me the square root of 2 over 2. Now we're ready to label the new triangle, the new 45, 45, that has a hypotenuse of 1 with these new sides, which would be the square root of 2 over 2 and the square root of 2 over 2. So looking at these triangles, we are going to fit those into our circle for the unit circle. It is called the unit circle because it has a radius of 1. So by making the hypotenuse here all equal to 1, we can find the sides of our unit circle. So I'm going to go ahead and put our blank unit circle here so we can talk about that one. So we looked at our 30 degree angle, which is this first one. So this first angle on our unit circle is our 30 degree. And last class we said 30 degree in radians was pi over 6. So we are looking at our first one, and this would be the triangle given that we just looked at with a 30 degree angle here. We have cut that first one into this small section here so that we can look at it closer. It says using the label 30, 60, 90 triangle from number 2, identify the coordinates point P. So we have taken that first quadrant of that unit circle here, and we are looking at the one that is 30 degrees right now. We just looked at this triangle and we said that when the radius is 1, and we know that the radius goes from the center of the circle to the outside of the circle. So this point right here, the radius has to be 1. Now, if we drop that vertical line right there, we'll end up with this triangle, the 30, 60, 90 triangle. And we said when the hypotenuse is 1, then our side here is 1/2, and our other side is the square root of 3 over 2. So I'm going to go ahead and label that. This right here would be the square root of 3 over 2, and this one would be 1/2. Now, when we talk about this point on the circle, because that's what this is one point on the circle. That circle keeps going, and all of these are points on the circle. So if we wanted to come up with the coordinate pair that goes with this point right here, since the center of the circle is at 0, 0, and the length of this triangle is a square root of 3 over 2, then the x value that is straight up from that point would have to be the square root of 3 over 2. For our y value, this is the origin, so the y value here is 0. If we're up a half unit to get to this point, then our y value there, our corresponding one, would be 1/2. So let's go back to our blank unit circle here real quick. Back to our 30-degree here. We are saying this is the square root of 3 over 2, and this is 1/2. So now we have filled out our first angle here for the unit circle. This radius was 1. If we dropped a vertical line, we ended up with a triangle that allowed us to find these ordered pairs. All right, to talk about the SOHCAHTOA there, the sine, the cosine, and the tangent, we're going to talk about that for all of these, but we'll start with cosine and sine. So this is my 30-degree triangle. So the sine of that is opposite over hypotenuse, and the cosine would be adjacent over hypotenuse. So we're going to set that up here. Cosine is adjacent over hypotenuse. And so my adjacent is the square root of 3/2, and our hypotenuse is 1. Now, anything divided by 1 is itself. So that's the square root of 3 over 2. For our sine, that is the opposite over the hypotenuse. And so that would be 1/2 over 1. Anything over 1 again is itself, so this would be 1/2. Since this is the unit circle, and it's called the unit circle because the radius is 1, so it's 1 unit, it's always going to be 1 in this denominator. So we see here that this right here came out to be the x value of that coordinate, and this one came out to be the y value. So the cosine of 30 was equal to the x value, and the sine of 30 was equal to the y value. Now we're going to try a second one here. It says, using the labeled 45, 45, 90 triangle from number 4, identify the coordinate point for P. So this time we're going to do the 45 angle here. And in that case, here's our 45, 45 that we labeled. Our hypotenuse was 1 again, which we knew because the radius has to be 1. And then the opposite side is square root of 2 over 2, and the adjacent is square root of 2 over 2. So for this triangle here, we're going to have the square root of 2 over 2, the square root of 2 over 2, and there's my radius of 1. To find this point on the circle, so we need our ordered pair. Again, this is the center, so it went over 1, square root of 2 over 2, and up square root of 2 over 2. So our ordered pair is that. Back to my blank unit circle here. We're going to go filling that out as we go. So this is our 45-degree angle. We did talk last time that that was pi over 4. So that's going to go right there. And we just discovered that is the square root of 2 over 2 and the square root of 2 over 2. We've almost got that first quadrant filled out. All right, in this case here, we have the cosine of 45. And so we know that the cosine is the adjacent over the hypotenuse. So again, we get the square root of 2 over 2 over 1. Anything over 1 is itself, so we get the square root of 2 over 2. For the sine, it is the opposite, so that's the square root of 2 over 2 over our hypotenuse, which is 1. And again, we get square root of 2 over 2. This time we notice that the cosine of 45 degrees is equal to the x value again. And the sine of 45 degrees is equal to the y value. There's a lot of patterns that go into the unit circle, so hopefully you're catching on to them as we go. All right, we're going to look at one more, that 30, 60, 90 triangle again. But instead of having the 30 this time here, we've got the 60. So we've rotated that triangle a little bit. Across from the 30 on our triangle, here it is right here. Across from the 30, we have the 1/2, and across from the 60, we've got the square root of 3/2. So I'm going to label that one here. Across from the 60, we get the square root of 3/2, and across from the 30, we get 1/2. And then, of course, our hypotenuse is 1. So now that I've labeled my triangle, again, this is the center of the circle, and this is a point on the circle that is at 60 degrees. To find its corresponding ordered pair, we drop a vertical line here. From 0 to here, it is 1/2. So we want 1/2 to the right, and then up square root of 3/2. So our point is 1/2 and square root of 3/2. For the cosine, that's adjacent over hypotenuse. And anything over 1 is itself. So there's our 1/2. Now for the sine of 60, that is the opposite over the hypotenuse. And again, anything over 1. So that's the square root of 3/2. Again, we find that the cosine of 60 degrees was equal to the x value, and the sine of 60 degrees was equal to the y value of that point. That's a pattern that you've got to recognize. The cosine is always going to be the x value, and the sine is always going to be the y value. So you can spot them very quickly if you memorize that unit circle, then you should be able to give the sine and the cosine immediately, because the x is the cosine, the y is the sine. Let's go back to our blank unit circle and fill out the new ones that we've got. So now we just did the 60 degree. And that is pi/3. I don't know why I wrote that one differently. Let's just keep it the same. And the ordered pair we just found was 1/2 and then the square root of 3/2. So we have almost filled out the first quadrant here. The next thing this wants us to do is think back to the 90 and the 360. And it says, given that the radius of the circle is 1, what would the coordinate point be there? So let's look at our unit circle here. This is the 90 degree, which we said was pi/2. If this is the center of my circle and the radius is 1, so we found this is 1, this is 1, this is 1, this also has to be 1. Since the x value on this right here is 0, then this would be 0. And if this is 1 unit long, then my y value would have to be 1. So that's actually easier to get. So we can go back and do that 0 degree, which is also 0 radians. Here is my center. And so the y value at this from the center there, if I go horizontal, is 0. So that's going to stay there. And if I go 1 unit to the right, that would give me the point 1, 0. Since we're at it, we'll go ahead and do this side here. This is 180 degrees, which we said was pi. And so center out here, same y value, so it's got to be 0, but its corresponding x value is -1, 0. That's what this point on the circle is. That's what we're doing, is finding those points that correspond with that. Down here, we've got 270 degrees, which we said was 3 pi/2. And so this right here is going to give me the point 0, -1. It's got the same x value as my center, and it is going down 1 unit. And when we go all the way around, we have 360, and we said that is 2 pi. That does have that same point of 1, 0. We're going to continue the unit circle on the next lesson, but I do want to go back and review because we did go through all of the degrees and radians for these. So just a quick review. Our special right triangles here come with the angles 30, 45, and 60, and then 90 is our top one here. Well, this next angle would be 30 units. Sorry, this next angle here would be another 30 degrees. So that would be 120. The next one would be 45 degrees further. So that is 135. And then our next one here is the one that is 30 from the 180. So that is 150. You should at this point be able to give all of the degrees of our unit circle as we go around. So we'll keep going from 180. This is 30 more. So this would be 210. The one in the center here would be 45 more than that one. So that's 225. From the 180 to get to this point right here, that would be 60 more, which is 240. Another 30 to that 270. Then we go from 270, we've got 30 more degrees this way, so that's 300. And then 45 from here would be at 315. And then 330 for our 30 degrees from this point. So we've got the full circle. These are all of the special angles on our unit circle. All right, for our radians, we talked about that too. These do correspond, so these are the ones that we're going to use on all of our special angles. It's cut into pi over 6, pi over 4, pi over 3, and pi over 2 here. This next one here would also have a 3, a 4, and a 6. For its numerators here, we are right here, we had pi thirds. Now we have another third. So this would be 2 pi thirds. And when we broke it up into fourths, we had 1/4 and 2/4. And so here we have 3/4. And then when we broke it up into the sixth, here we have 5 of those sixths. And then the total one would be at pi here. All right, for our third quadrant there, again, we're going to have those same denominators, but it's going the other way here. So this one is going to be a denominator of 6. This is going to be a denominator of 4, and this is going to be a denominator of 3. Now we have a full pi here, so that would be 6 over 6. And then we've got one more. So this is 7 pi over 6. In this case, this would be 4 over 4 to give me that single pi. So if we're adding another one, that's going to be 5 pi over 4. And then for our 3's, that's going to give us 4 pi over 3. Hopefully at this point, you've looked at some of the different patterns. You see that over here, it is 1 over the denominator, 1 pi. In this case, if you look at these are all 1 less than the denominator. So a lot of people remember that as d minus 1 over d. So your denominator minus 1 over the denominator to get the radians in that one. Here you see these are all 1 bigger. So this would be d plus 1 over d to get those radians. Again, there's a ton of patterns. You can even find your own patterns that you can go by to remember this. All right, on our last quadrant, again, we're going to have the same denominators. So that's going to be 3, 4, and 6. This is the hardest one to see because you've already added all of these and now you're adding more. So this is going to be 5 pi over 3, 7 pi over 4, and 11 pi over 6. And a lot of people, to remember that one, do 2 times the denominator minus 1 over the denominator. So 3 here times 2 would be 6, minus 1 would be 5. And 4 times 2 is 8, minus 1 is 7. 6 times 2 is 12, minus 1 is 11. So that's how you can remember the radians if you want to. There's tons and tons of different patterns again to remember those. We're going to stick to just this first quadrant here, and next lesson we'll go ahead and finish out the unit circle as we go through, but we've got a couple more things to talk about. To remember this first quadrant on the ordered pairs, a lot of people use their left hand. So if you have your left hand in front of you, they consider this right here, the 30 degree, the 45 degree, and the 60 degree. So this would be considered 0 degree and 90 degree. But you can remember the ordered pairs using your fingers. So if we were trying to find the 30 degree, you would fold this in. All of our points are over 2, so this is going to be over 2. This would be our x value. That one comes first, and so that's the square root of 3 over 2. And then this would be our y value, and so that would be 1 over 2. If we did the 45 degree one, then we would bring in our middle finger here. And so we've got the square root of 2 over 2 as our x value, and then the square root of 2 over 2 as our y value. So that's our 45 degree, which is this one right here. If we bring in our pointer finger here, that's going to give me my 60 degree one, which is this one. And so that's 1 over 2 for x, because x comes first here. And then the square root of 3 over 2. So your x is always on the top and your y is always on the bottom here. And so that kind of helps you. That's another trick. We did put that at the end of your packet notes there. So we put a little diagram if you want to look at that. Again, there's a ton of different ways to remember it, memorize it, but you really got to know that unit circle and know it really well. We will be timing you on it. All right, for the last little bit that we're going to talk about, just to go back, we said that 90 degree was 0, 1, and 360 was 1, 0. So we want to talk about those special angles for our cosine and sine. So we said cosine is our x values, sine is our y values. Make sure that you learn that part of it. So if cosine of 90 would then be 0, sine of 90 would then be 1. The cosine of 360 would be 1, and the sine of 360 would be 0. So I can look at just the ordered pair. This is my cosine, this is my sine. If you want to think about it this way, that's what the ordered pair looks like. All right, so here's a little bit more on why that works. So let's talk about that. On our unit circle here, it tells us that the sine of theta is y over the radius. Since the radius is 1, then it's just y. So cosine is going to be our x values, sine is going to be our y values. All right, so part of your quiz, and where I said we're going to time you, is you filling these out and knowing them really well. So given a chart like this, you should be able to fill it out quickly. 30 degrees we know is pi over 6. Now for the cosine, sine, and tangent. So cosine is my x and sine is my y. So those are the no-brainers that should go really fast. If you're using your hand, there it is. That's the square root of 3 over 2 and 1 over 2. So square root of 3 over 2, 1 over 2. Tangent is the one that's a little bit harder. It tells us right here, tangent is the sine of theta over the cosine of theta. So that is y over x. Now, if I do that here, I would get 1/2 over the square root of 3 over 2. When we do fractions, we keep change flip. So we're going to keep the 1/2 and flip the 2 over square root of 3. And so that is going to give me 1 over the square root of 3. Now we don't leave that like that. We have to rationalize. So we multiply times the square root of 3 over the square root of 3, which gives us root 3 over 3. So that's the one that takes a little bit more work, but it's just taking that y and x and manipulating it. All right, 45 degrees, which we said was pi over 4. That's the one that we turn the middle one in. So we've got the square root of 2 over 2 and the square root of 2 over 2. For our tangent, we would do y over x. So if I put this divided by this, they're both exactly the same, and anything divided by itself is 1. For 60 degrees, that is pi over 30. Sorry, over 3, what am I saying? And so 60 degrees is this one. So that is 1 over 2, and then the square root of 3 over 2. In this case, we have switched this x and y right here. So we know it would be the reciprocal of this one. So that is the square root of 3. For 0 and 360, that's going to be 0 or 2 pi for radian mode. We said that's the 0.10, so the cosine would be 1. The sine would be 0. If I take 0 and divide it by 1, I get 0. For 90 degrees, which is pi over 2, that's our 0.01. And so 0, 1. If I divide this, 1 divided by 0, you cannot divide by 0. That is undefined. For 180, we're talking about pi there. That is -1, 0. If I divide, 0 by -1 is 0. For 270, we're talking about 3 pi over 2. We said that is 0, -1. If I divide, again, I got that 0 in the denominator, which does not work, so that is undefined. And that's as far as we're going to go with the unit circle. I do want to remind you, when you're plugging these into the calculator, you must be in the correct mode. So when asked to do a degree, you need to be in degree mode. When asked to do a radian, you need to be in radian mode. You know that by looking at this. This is written as a radian, so I know this is radian. This is also a radian. It does not have a degree symbol, so this is a radian. This one here has a degree symbol, so this would be degree. So you would want the calculator in degree mode here, and you would want the calculator in radian mode here. So sometimes on one test, you will have to switch from one mode to the other in order to do that. So quick reminder, you go to mode, and then you're going down to this part right here where it says radian and degree. Right now I have it in degree. If I highlight it and hit enter, it will change it to radian. And then I can do the cosine of 2. And so our answer, we do keep that in 3 decimal places. Sorry, got a little glare there. There we go. You would want to keep it to the 3 decimal places. So this would be -0.416. Now to do this other one, tangent of 37, again, I would go to the mode, and this time I would change it from radian to degree. Now I can do the tangent of 37. If you don't do that, you're going to end up with the wrong answer. So make sure that you're careful with that. We keep our 3 decimals, so 0.754 would be the answer to that one. So we're going to stop there for this lesson. Next class, we'll go ahead and do the second part of unit circle.